This to me, right there, is chemistry. This is a redox reaction. We're going to have a look at what we mean by redox reactions. And it is fun, but that's at an industrial level, and I can't do that in school. But I can do this. This is called the thermite reaction. It is amazing. It's easily done. I'm not going to tell you how to do it because it's so dangerous if you don't know what you're doing. And the truth is, you've got to, as chemistry teachers, we have to do a whole course on health and safety. That is hot. That is liquid iron coming out the bottom. Okay, it's called a thermite reaction, and this is how you extract iron. Okay, this is how we do it in school. This is how they do it on railways. This here is the industrial extraction of iron. Iron doesn't exist like iron. Iron exists like this, iron oxide. Okay, and that's no use. It's just like a rock. And what I mean by iron oxide, this is iron ore. It is iron bonded to oxygen. And in this process of extracting iron, you get rid of the oxide, you get rid of the oxygen. That's why this is called reduction. But we'll come back to that. This is true of all metals. All right, you have to get rid of whatever is, in this case, oxygen. So aluminium looks like this. This is aluminium. Okay, this is the ore of aluminium, which is called bauxite. That's how it looks when you dig it out of the ground. That's what we want it to end up at. So this here is aluminium oxide. Aluminium oxide. And you get rid of the oxygen and you're left with aluminium. I hate typing on these things. So as you can see, this is aluminium oxide on the left. That's how we find it. This is aluminium ore or bauxite. It is aluminium with oxygen bonded to it, aluminium oxide. You want to get rid of the oxide and be left with pure aluminium. And that's what it looks like coming out. It's like Lord of the Rings. No, not Lord of the Rings. The Hobbit. Love The Hobbit. And it's the Battle of the Five Armies when they take on Smaug. So, in the same way, you can have liquid gold, but this is liquid aluminium. It's pure, hot, liquid aluminium. It is not aluminium oxide. So reduction is getting rid of that oxygen. So the opposite of reduction is adding oxygen. And there's lots of different things that you will see where we're adding oxygen. One of them is burning stuff. Burning wood. You are adding oxygen to the wood. And that is what fire is. It is the oxidation of wood. This is oxidizing stuff. This is copper, and you can make statues out of copper. And they react over years. They react with the oxygen in the air, and they form copper oxide. And that's generally black, but here you can see this kind of bluish copper oxide. Rust. This is made from iron. This is iron oxide. Okay, in all these, you are adding oxygen. So it's oxidation. And this is what I love. Can you imagine I get to do that? Well, I get to do that. It's so brilliant. And your job today is we're moving on from organic to here, reactivity series of metals. And we're only looking at oxidation reduction, and it's about learning the words, as it always is. So, oxidation. Adding oxygen to a substance and what it looks like. Metals going rusty. So we have iron, you add oxygen to it, you go to iron oxide, what we normally call rust. Burning stuff like wood, coal, oil and gas, that is take a fuel, add oxygen to it. The more you are adding oxygen, it is oxidation. Okay, and I showed you a picture of metals reacting with air. All right, and that was copper, add oxygen, forms copper oxide. Right. And we would say the copper has been oxidized because oxygen has been added to it. All right. Oh, someone went ding. Ah, where's my work? Have I shut down? No, I haven't. It's over there. All right, so, and here's some examples of oxidizing. Rust, We're fine. But here's a weird one. Apple slices, when you cut them, go brown after a while. It's the oxygen reacting with the surface. Your apple is becoming oxidized. Burning stuff like wood and coal, right? Oxidation, oxygen is added. All right. Now the opposite of that is reduction, removing oxygen. The one I just showed you where you have all this hot metal flying around is when you get pure metals from metal ores. Metal ores are metal oxides. You are doing the opposite of oxidation. And you can also use it for cleaning dirty metal. All right. Now, if we look at this equation here, it never happens by itself. What I mean is, we call these redox reactions, right? They never happen on their own. You just cannot have oxidation. Okay, we'll look at why. If you look at this equation here, you've got zinc oxide and carbon. Now, if we look at the carbon, it's going to form carbon monoxide. Here we go, CO. It is being oxidized. It has oxygen joined onto it. But if you look at the zinc, well, the zinc has lost the oxygen. It has been reduced. Okay, oxidase. That's just disgusting. Let me write that properly. So the zinc has been reduced. It was zinc oxide. Now it's lost the oxygen. It is now zinc, so it's been reduced. Okay. Now, real world examples is the two most common, like industrial chemical processes you're looking at, is extracting metal. Okay, so if you have iron oxide, which is hematite, and you remove the oxygen, you end up with iron, pure iron. This is the extraction of iron. This is reduction. The kind of non-common ones you look at is cleaning. Cleaning some metals, when you remove the rust, chemically, that's reduction. Okay. Now, this is what I talked about. They both happen, redox reactions. Here's the zinc one I talked about. All right. So redox to me is like a tug of war. It's a big fight. One up here, carbon wants to steal the oxygen. It is bad. It's literally ripping the oxygen off and running away. Okay, so simple rules to remember. Oxidation is oxygen added. Reduction is oxygen removed. And they always happen together in redox reactions. Okay, if I look at this, magnesium is being oxidized. All right. Here, hydrogen is being oxidized and copper oxide is being reduced. Okay, now, common student mistakes. Reduction makes things smaller. This is not English. We are not using, we might use English words, but we are not speaking English. We are speaking science. Reduction means removing oxygen. Another misconception, you can have oxidation without reduction. Nope. They always come in pairs. Only metals can be oxidized. Nope. Like carbon. Carbon can be oxidized. Okay. So, what you guys are going to do, you've got these questions to do. All right. And it is literally just going through oxidation reduction and looking at their names, what words go where. Okay. So, I hope I've explained enough of that. I'm